Hi, today we're going to be going through an OpenRocket tutorial. The version is 23.09. You might have a later version, but it's generally how it works. At the end, we also have a surprise for you. Alrighty, let's get into this. Here I've made an example rocket for you guys. We can see that the diameter is 26 millimeters, the apogee is 150 meters, and the stability is 2.56 cal. This is what a correct rocket should look like. We can even check out a simulation of the flight. We can see here that the apogee was 150 meters and the engine burned really fast. I'll close this now. Let's get into building our own one from scratch. I'm going to start off by pressing sustainer and I'm going to add a nose cone. I'll close this pop-up and I'll make the base diameter 26. I'll also make the length 130 millimeters. I'll change the component material to PLA. I'll change the component finish to smooth paint because I'm going to sand it very nicely. Now I'll add a body tube. Change the length to 300, but keep in mind this is your own rocket, you can do whatever you want. I'll change the wool thickness to 1. I'll change the component finish to smooth paint. Our diameters are correct. Now what I'm going to do is I'm going to make a shoulder slide into the body. You can see the shoulder appeared, but it isn't the correct diameter. I'm going to make it 24. I'll also make the length 10. Now we have the base for a rocket. Let's now add some fins. You can select trapezoidal or freeform or elliptical, but I'm going with freeform. I'll change the number of fins to 4 just to make it safer. I'll also change the thickness to 2. I'm going to change the shape in this tab, and I'm going to make it look very nice. About that seems good. You can also change it perfectly here, so I'll change this to 27. Alright, the fins look good for now. Now we need a space to put the engine. We'll make the inner diameter 18 and the outer diameter 20. We'll also make the wool thickness 1. The inner diameter of the engine tube must be the same diameter as the outer diameter of the engine. I'll go into motor and change this component is motor mount to tipped. Okay, you can see that the engine mount is in the rocket. Let's go to motors and configuration and add a new configuration. Here is where you can choose your engines. You can select total impulse, motor dimensions, and manufacturer. I just want to S-TES and Quest. I'll choose this Quest C12. Now you can see we have an engine inside of the rocket. However, the tube isn't long enough, so I'm going to extend it. I'm going to go back into general and change the length to 90. That's good. Now the inner tube can't really be floating, so I'm going to add centering rings. Stop. Okay. I'm going to close this other pop-up and I'm going to make the thickness 2. I'm going to make the outer diameter 24 because that matches with the rocket. I'm going to make the inner diameter 20. This matches with the outer diameter of the inner tube. I'm going to press OK, and I'm going to duplicate it by copying it and pasting it using Ctrl-C and Ctrl-V. Now, I'll make the placement top of the parent component, and I'll change this to 0. That looks good. Now we're going to add a parachute. I'll go into Body Tube and select Parachute. I'll also change the canopy diameter to 200 and the material of the shroud lines to Kevlar thread 800. I'll change the line length to 400. The material of the canopy is good. In the placement, I'll also change it to about +20. Now, I'm going to add some shock cords. So, select shock cord, and I'll change the position to +40. That doesn't seem to be enough, so I'll go +50. There we are. Shock cord material should also be Kevlar thread 800. Now, I'll change this to 500. Now I'll press OK. We're going to assume that the parachute is connected to the shock cord, and the shock cord is connected to the nose cone in the body. To show you how to add a hook, we'll do this. We'll go into nose cone and we'll add a mass component. I'll change it to bottom of the parent component. Now, I think the diameter would be about 12, so I'm going to slide that down. I'll also change the length to about 18, yes. Now, we need to be careful to change the mass, so I'm going to change that to about 5 grams. I'm going to move this a bit more forward, so I'm going to change that to 10. And I'll rename this to hook. There we are. We've got a pretty good rocket. Did you notice that the blue dot moved forward? That's actually quite important, and we'll talk on that later. Now we're going to make some launch lugs for the rocket to hold onto the launch rod. Select Body Tube and go Launch Lug. In this Choose Component Preset tab, you can choose pre-made launch lugs, but I won't be doing that. I'll be making my own. I'll make the length 20. I'll also make the thickness 2. And that seems good, but we need to add another launch lug. Change the instant counts to 2, and I'll change the separation to about 100. Now I'll change the material to PLA. I'll actually change the instant separation to about 120. That looks good. Alright, now we can roll the rocket around in the view. You can see that the rods, which are indicated here and here, one of them is inside of the fins. This is not what we want. I'm going to select Launch Lug, and I'm going to change the rotation to 135. This is 180 minus 45 degrees. Now let's see. That is good now. Now we've got a rocket that is looking very good. Let's see if we can optimize it, because the diameter is 26 millimeters, the length is 430 mils, and the apogee is 227 meters. We've got a bit too much stability, which is 3.52. I think we can trade some off for apogee. I'm going to change the shape to make it a bit smaller. Now we've gotten the rocket much higher, and we have stability at 2.42 cal. I reckon that this is good. We can see that we've gotten a much higher apogee at 272 meters. When changing the stability in apogee, you can add more weight up the front, you can change the fins, or you can change the tube length. You want to get a nice balance between stability and apogee. I would recommend that the stability should be 1.5 cal at minimum, however 2 is decent. Anywhere from 2 to 6 cal is good, but for smaller rockets, it should be 2 to 4 cal. Let's just run a new simulation because we've gotten a bit higher. We have the launch conditions here, which are all good, and we have simulation options here, which are also very good. I'll press simulate and plot, and I'll press plot. We can see that the engine has a very, very quick burn, and it coasted for about 5 seconds. We can see that with the yellow and orange line. With the blue line, we can see the altitude. We can see it went up to 270 meters, parachuted down safely, and the entire length of the flight was about 48 seconds. Keep in mind, however, that this is all a simulation and it could be wrong. Typically, if you change all the weights of the components and the materials, it should be very accurate. However, if you don't, there could be some errors in calculation. Let's say that we have weighed the nose cone and we already know the weight of it. We can go into nose cone and we can press override. We can press override mass. We can see that's 15.8 grams. I'm going to assume that it's 20. Here we can see that an icon is popped up. This means that it's been overridden. Now, the apogee is 266 meters. That's a bit worse, but it doesn't matter because we've weighed it already. Now, the blue dot is the center of gravity and the red dot is the center of pressure. They should be at least 1 d apart, and d is diameter. You can see the length between them here up in the top right. This is good. We've gotten more than 26 millimeters spaced apart. The center of gravity must be more forward than the center of pressure, otherwise it is not safe to fly. Now that we've weighed every single component, we can go up here to File. We can press New, Open Recent, or Save. We'd want to save. I hope you enjoy designing and building your own rocket. Tell me about it in the comments.
Okay. 5, 4, 3, 2, 1. Whoa! Oh my gosh, I need to catch that!
Oh my goodness!